In this video, we're going to go over numbers and number type variables. So there are three types you deal with. Typically, you'll have integer type numbers, you'll have float type, and you'll have complex type. And you'll probably just deal with integers and floats. Complex is a somewhat rare situation. Now, you're going to encounter many of the same math functions you've seen. There aren't too many you can work with here, but let's just start by looking at some of them. So we're going to start with value 1 equals 10. Notice this is an integer because it haven't added a decimal to give it some sort of precision. We have value 2 equals, I'm just going to say 2 here. Now let's look at arithmetic operators. There we go. Arithmetic operators. So these are things like addition, subtraction, multiplication, etc. So for our arithmetic operators, I'm going to go ahead and say my addition answer. So the answer after I do addition is going to be a variable name, and the value of it is going to be the value of my variable value 1 and value 2 added together. So let's just go ahead and run these two. In our variable explorer, we can see those have values 10 and 2. And when we add them together, we get 12. And so when I run this here, 12 is assigned to the variable name addition Intz. Perfect. So that matches. That's great. That's addition. Super simple. Subtraction is as easy. You just do the minus sign. We get 8. We'll go ahead and call this subtraction. I think that's right. Subtraction answer. Okay, so then we can go ahead and do division. We'll just say divide answer. And that would be value 1. And we'll use the / value 2. So 10 over 2. 10 over 2, that should be answer 5, so we get 5. And notice with the division, it's going to return it as a float. We get 5.0 there. And then we have the multiplication answer, which is value 1. We use the star times value 2. And this is going to give us 20 as an integer right there. And then we can get the powers. So to use a power, what we're doing is we do the double star. So value 1 raised to the. So the double star means raised to the. I'll say value 2. So in this case, we get 100 because we have 10 squared, essentially, is what this says here. Great. Now we did this with 2 integer values. Now I can make this a float. Notice it works with just the period, but I'm going to put the 0 on there because it's more aesthetically pleasing to me. So now, see how we had a couple floats, but most of them were integers on the answer? Well, now they're all going to be floats because we have a float working on it. So the only thing that's an integer up here, after we went through all of this code again, is value 2, which is defined as an integer. Now we can do the same thing with our complex numbers as well. This will work for all of these. So we'll go through. Value 1 is now complex. Value 2 is just normal. So it's going to add the real part together. And we go through here. And these are all going to be complex because they'll have a complex component. You'll notice even if this is 0j, it's going to be complex. And these things will stay complex as well, even though they don't have, like technically they don't have a imaginary component. The variable stored as complex because it was doing an operation on a complex type variable. So those are arithmetic operators. We also have floor division we can use. And so what floor division does is essentially it says how many times you can divide by a whole number. So let's just go ahead and look at this. Let's go ahead and print 100 divided by 6 when we do a floor. And that's down here, that's 16. So let's look at what 100 divided by 6 is by itself without the flooring. And that gets us 16.6666. So essentially what that tells me is 6 times 16 is going to get me as close to 100 without going over as possible. So that's 96. So a floor division is going to return that value. The number of times I can multiply without going over, essentially. Okay, and then kind of complementary to floor division is the modulo operator. So that's a modulo. That's a percent sign. So if we do the same thing, 100 mod 6, it's going to return the remainder. So we saw here that 6 times 16 gives us an answer of 19. Well, 100 mod 6 is going to give us an answer of 4, because we can divide by whole numbers up to 96, and what's left over is 4. So we'll go ahead and print that out. We see that there. So I'm just going to go ahead and change this to say floor answer equals 100 floored by 6, and then we'll call this the mod answer, which is 100 modulo 6. So get the remainder there. Okay, so that covers most of like the mathy stuff in terms of like add, subtract, etc. I do want to take a moment to talk about the difference between ints and floats. So let's say we have a string. We saw in the last, this is the string, in the last video I made where I talked about strings, hopefully the one you watched right before this, we saw that you could do slicing. Now, I'm going to go ahead and make a variable to hold my string slice, and I'm going to go ahead and try to slice my string using a float 0.0 up until 3, or 4 here. So I'm going to define my string. So here's my string. I'm going to try to slice, and it's going to say slice indices must be integers or none, or have an index method. So essentially what it's saying is a float value, because it doesn't have a precision, doesn't tell me exactly 0, so I can't actually grab 0.0. I have to grab the integer of it. So now my slice works just fine. So what happens if you only return floats? You go through some fancy code and you get a float out, and you need to put that float to slice a string or to grab something indexed at a location. Well, we can convert back and forth between types. So let's convert back and forth between types, okay? Let's go ahead and say, here we have int versus float. So floats don't work for indexing, essentially. So this requires an index method. Floats don't have it. So if we want to convert back and forth, it's pretty dang simple. So if we want to make a float into an integer, so we'll do a float into int. What we can do is we say int. So this is the integer class. Then we give it the float we want. So in this case, it was 0.0. If I run this, float into int gives me an integer at 0. Now what happens if it's like 0.3? Well, it's going to floor it down to 0. And if it's 0.99999, very close to 1, it still floors it. You notice that? So it's this operation, essentially. So it's always going to round down to the nearest integer. Now we can convert the other way as well, in case that's what you want. But maybe more interesting is we can do complex numbers as well. So we'll do complex, and we can put in 0.13. And watch when I run this, when the variable named complex is made, watch its value. So complex here, it again has that imaginary component, but it has a value of 0. So it's essentially not there. But once we have a complex number, we have to do something special to extract the real and the imaginary parts back. So if I want a float from complex, what I can do is I can say complex number, and then dot real, and then that gives me that float. And then I can do dot imaginary. Oops, one sec. Imaginary, there we go. And there we go, we get 0.0, that float. So then if we wanted to return an integer from a complex, what we have to do is we'd have to do int, and then get the imaginary component of the complex. So this is how we go back and forth. So this one, we took a float and we converted it into an integer. We took a float, we converted it into a complex. We took a complex, we converted it back into a float, looking at the real component. We took a complex and converted it to an integer, looking at the imaginary component. Now, perhaps the last thing you may end up doing quite a bit, this is something I find myself doing more than I expected, is you're going to want to print something, and you're going to want to return your float value within the print. So let's say print fancy string with float in it. So let's say you did a calculation, and your float value is equal to 12.128919. Now you know based off your calculation you should only have 3 significant figures after the decimal. So how could we get that? Let's say we're printing this off. The value is, or we'll say there is a total value of, now we're going to do something fancy. These brackets are going to be where our value is going to go. So pretend this is the number you want in this data. But what we're going to do is we're going to put a colon, the number of significant figures we want. So it says, give me everything to the left of the period and give me 3 significant figures to the right of it. And then we're going to indicate that it's a float value. And then we're going to finish off by telling this print function that this is a string that's being formatted with a float value. And float value is just any float. In our case, this is just the name of the variable. If we called it value, then value would go in here. Or you could put it straight in there like that. Okay, so now watch this. We're going to get float value over here. Then we're going to print this. And we have a small error. So this unexpected EOF while parsing, this tells me that either I didn't close off my string, but you can see I did, or I didn't close off something else. So in this case, this parenthesis, notice how it's red instead of green. That means it doesn't have a closing parenthesis. So I'll add that here, and now we get a finished off function. And that syntax error is going to go away, and now we have there's a total of 12.129. See how it rounded for us in this data. So now we have that fancy sentence. And this should be good for strings, this should be good for numbers. And that was your float type, which has some type of precision, your integer type, which is like a counting number, use it for indices especially, or for slicing, and your complex type, which you might encounter every once in a while, and it might be useful to know how to do math with it through Python. Good luck.